Hello, today we're going to talk about rate of change. To evaluate a rate of change, first thing we need is a function. So let me draw my y-axis and my t-axis in this case. This will be t and that's going to be y. And let's give myself an arbitrary function, something like this. Now when we talk about rate of change, I'm going to be talking about the rate of change between, let's say, this point right here and this point up here. Now what rate of change really means is the change in y over the change in t. So when I look over at my function, I see the change in y, well, I'll be going up like this, over the change in t, where I'll be going over like this. This is essentially the same thing as rise over run, which would measure the slope of this line. In this case, we'll be calling this the slope of the secant line, and that will represent the average rate of change. So average, actually let's write it down here. Average rate of change is the slope of the secant line. Alright, the other rate of change we'll be talking about is going to be the instantaneous rate of change. Now, when we measure instantaneous rate of change, we'll be measuring it at one point, not two. So the rate of change at this first point, my purple dot on the left, would be if this dot increased at the same slope as it was present on the line. So essentially it'd be going in the tangent line such like this. So if this point was unhindered by the rest of this function and had the same slope that it did at that point, it would continue in this line. So the instantaneous rate of change can also be considered the slope of the tangent line. At that point x. Now how we'd write the change in y over the change in t as a function, well, change in y is going to be the difference between the y value right here and the y value right here. Well, that's going to be the f of t2 minus f of t1 over the change in time. Well, that's going to be the time value here at t2 minus the time value here at t1. Let t2, call that t1. So this is simply t2 minus t1. And this is the average rate of change between times t2 and time 1. Now if we're talking about the instantaneous rate of change, I'm only going to be concerned about the slope at one of my points, t1 or t2. In this case, if I wanted to know the slope at time t equals 1, I would keep the same equation here, f of t2 minus f of t1 over t2 minus t1, but I'd be evaluating the limit as t2 approaches t1. This function still gives me rate of change just like it does for the average, but because we're focusing on just this one time, it'll give me the instantaneous rate at that point t1. Alright, one last thing to consider is that a lot of times calculus books will have this formula written a little bit differently by using the letter h. What they're doing is making the substitution where h equals t2 minus t1. If we look at how this rate of change equation will differ when we plug in an h, instead of having f of t2, we're going to have f of t1 plus h. We'll leave this one the same since they both have t1. And then this whole thing, t2 minus t1, is the same thing as h, so this is all over h. This would be the new way to write the average rate of change. And likewise to before, when we wanted to evaluate the instantaneous rate of change, we'll be taking its limit. And instead of the limit of t2 approaching t1, we'll be subtracting t1 from both, and then t2 minus t1, again, is just h. So the limit of h approaching t1 minus t1 is just 0. So this is the limit of h approaching 0 of our rate of change function.